Okay, my clock says that it's on the half hour, so I think let's get started on time. Welcome to the CBOR Working Group at IETF117. I'm Barry Lieba, one of your chairs, and Christian Amsus, who's online, is the other chair. Christian, say hey. Hey. There you go. He took me quite literally. Okay, the usual stuff. Note well. Note it well, because it's the note well. This tells you what your responsibilities are when you participate in IETF sessions and other IETF activities. We also have a code of conduct, which I did not put in the slides, that you're also expected to behave civilly. This working group seems to be pretty good with that. I hope we continue that way. And
Barry, you weren't in the meeting that we had in the break before this meeting, so we can be uncivil.
We can. Okay. Karsten threatens to be uncivil sometimes, but I have yet to see that. So, okay. Anyway, a quick thing on dealing with IETF meetings these days. We have a special version of MeetEcho that works on mobile devices. And now there's even a real full version of MeetEcho that works on mobile devices. You must use that and scan that code that's up there on the screen if you are, or just enter the MeetEcho from one of the links in the agenda. If you are remote, you've already taken care of that because you're on MeetEcho and you're already recorded. But this is how we record the blue sheets now. There's also supposed to be a little thing floating around, which I don't think we have, that has that same QR code on it that you could scan, but just scan it from the screen up front. And that's also how you get in the queue to say something. So please don't just go up to a microphone, but use the MeetEcho app to queue yourself up so we can have proper queuing. Yes, if you want to control your own slides, that's possible through MeetEcho. So recommend that you do that. And that's it for that stuff. Here's the agenda. We have what we just did. You can't bash that part of it, but you can bash the rest of it. First, we're going to talk a few minutes about the documents that we're not going to otherwise talk about today. Then we have a couple of active working group documents to discuss. Well, more than a couple. The EDN literals document, which will be a pretty short discussion, and then the set of 3 CDDL 2.0 documents. Following that, some individual documents that are not working group products yet, but that are under discussion in the working group, DNS CBOR and the DCBOR work, the deterministic CBOR. And then we'll just go over what the interim call schedule is between now and 118, and then any other business, if there is any other business. Any comments on the agenda, additions, changes? Seeing none, let's head straight into the documents not under discussion today part. Time tag, the latest updates changed it to standards track from informational, and we did a brief final working group call for any objections to the most recent changes. We got none. So it's now on my queue to finish up the Shepherd write-up and put it into publication requested, which I will do right after the IETF meeting is done. PACT. Karsten's note on that is please suggest alternative table setups. And later when we talk about DNS CBOR, we'll talk about use case for PACT. Karsten, do you have any other words you want to say about either of these two documents?
I actually even have slides on them.
Yeah, sorry, you actually what?
Have slides on them.
Slides on them. Okay, well, let me go ahead and turn over the slides to you then. Stop sharing. Grant. Okay, head for it.
Okay. So you just mentioned time tag. I would just add to this that sedate is still somewhere in the bowels of the ISG right now, but I think our interface to that is stable, so we can decouple from that now. And anyways, we are not quite as advanced as they are, so there is no problem there. And even this one editorial we were still discussing, but we can fix this in the IETF last call. So my recommendation would be to ship this now. On PACT, we actually have a version -09 that has two ways of setting up a table, a common table setup and a split setup. Because when I tried to make it all common, I noticed that maybe that's not so right. And we should have a tag for split setup. So both are in there right now. And there is new text about what happens when you import a table using some other mechanism, and that leaves unpopulated space, and what do you do during unpacking then. So there is a way of doing undefined in this case. So we have a use case later today, but I think what we really want to collect now is implementation experience. So who else can interchange data that are in PACT format? That should be done in the next month or so. And if that turns out positive, then I think we are done. And there is also a draft I would like to point to from Christian, PACT by reference, that really complements the table setup picture by having the other totally essential part, which is getting your table from elsewhere. So please do read that one as well, and we probably should discuss this in the next interim or so. So that was PACT.
Okay, well, and you're next on the agenda, so I'll just let you keep going.
Yeah, so you said I was going to talk quickly about the EDN literal document and a little bit longer about the CDDL documents, but maybe I should put in one slide before that, which is this here. Really, CBOR comes with a number of languages, and it's good to be aware of them and to be aware of where they differ. So first of all, we have CBOR itself, which is the representation and interchange format. That's binary, that's concise, that's efficient. It's just very hard to talk about this on a whiteboard. So we have various forms of actually talking about CBOR, and one is a simple hex dump with comments, which is called CBOR pretty in the RFC editor list of formats that go into RFCs. That's useful, but it gets very long in the tooth when you have more complicated structures. So we have two more textual languages. One is the CBOR diagnostic notation, or usually call it extended diagnostic notation because it has been extended once. And this is what we use for examples in our documents and for diagnostics. And this is what this first draft, EDN literal, is about. So this is a text form for a single instance. It's not describing multiple instances, it just describes a single instance, which can be a CBOR data item or a sequence of CBOR data items. And it's easy to convert back and forth between that and actual CBOR, which is one of the functions that CBOR.me does. CBOR.me, of course, uses pretty format as the other side of that picture. It's important to keep in mind that EDN was derived from JSON, so it feels like JSON, even if we maybe have it more useful for humans. And of course, we had to add binary and tags and things like that, but fundamentally, it's still JSON. And then we have CDDL, which is a specification language and which we use for validation in programs. So in RFCs, we find specifications, and in programs, we find validation code. And that doesn't define a single instance, it defines a data model. So a grammar for CBOR documents. And that is inspired by ABNF. So it has a very, very different base syntax from diagnostic notation. even though they both have parts that look similar to each other, it's really something different. And it can work with anything that uses JSON's data model. So it can work with JSON, it can work with CBOR, and I even have a draft how to make it work with comma-separated values or CSV files. So that's really what you have to keep in mind. It's really easy to confuse diagnostic notation and CDDL, and it happens to me all the time. And the compiler then tells me that that was the wrong notation. Anyway, so on the diagnostic notation front, we had a draft that originally just was defining a little extension, EDN literals. That's why it still has that name. That was adopted in June. But pretty quickly, or I think even during working group adoption, there was a comment that we really need an ABNF for diagnostic notation. So that was added in -01. I left one Easter egg in there, so I'm still waiting for the first person to tell me this part is wrong. The next thing that was added right before this meeting was an appendix that has essentially the content of the previous slide. So it helps you understand what the difference between diagnostic notation and CDDL is, and actually provides examples for that. So this document is kind of, it's not urgent. We can use the things that are in there, but of course it would be good to get a review and actually to do implementations using that ABNF. So I think that's also up for review soon. And I hope the net result will be that we have these EDN literals, which are a good extension, but also an ABNF that we can put into all of our tools. So the other part that I'm supposed to talk 20 minutes about, I'm probably not going to be able to do that, but of course others may have questions, is the pack of 3 documents that will together be the first form of CDDL 2.0. The first one is essentially fixing the grammar, and yeah, that is pretty much done, I think. Again, more review would be good. This just became a working group document. Then we have the more control document, which is essentially the second installment after RFC 9165, which provided a set of additional control operators, including for ABNF. So that's something where people should look at their specification work and see, is there something that's difficult to write down because we don't have the right control operator. So for instance, we have a control operator right from the start of CDDL to put in a byte string with some CBOR data, with some encoded CBOR data in it. But excuse me, we didn't do the same thing for JSON. So if you want to write a spec where somewhere there is a little bit of JSON code, we currently have no way to define this in CDDL. So that's what the more control does. And the third one is the first part that really is CDDL version 2, a module structure for CDDL. And that is implemented in CDDLC. Actually, all of these are implemented in CDDLC, but that's really something you should be playing around at this point in time and building your larger specifications out of snippets that talk to each other using import or include. So again, all 3 are implemented in at least one tool. We need to test these out in actual spec work. There are enough documents out there that are using CDDL, so that shouldn't be too hard. We need to get reviews, and of course we need to get more implementation work. So again, this is something that waits for reviews. Any questions on the CDL2 pack?
I see Hank. I was about to see, I see no one joining the queue. And by the way, Karsten, you weren't expected to talk for 20 minutes. It's just that you had 20 minutes slot on the agenda. So you don't need to use it all.
Yeah, hi, Carsten, this is Hank. I think we have like 50 CDL fragments for CORAM, and I think we will use import include there.
Great, wonderful.
As soon as my co-authors re-sublimate in reality, they're gone at the moment, but yeah, soon.
Yeah, CORAM was an example I had in mind, of course, because that's really complicated and good.
Kirsten, I think that giving good examples of how ACE and CWT documents are structured will also benefit from using the modular structure. So
yeah, I think that's
assemble a few things.
That's a very good point. And my next slide is kind of saying the same thing, but on a different matter. So I think we actually have to sit down and write a few more examples, not necessarily in the context of a specific spec that we are trying to get written up, that of course also should contain examples, but a little bit larger examples that explain to people how these things fit together and can be used in actual specification work. That would be a good thing. And I think ACE and CWT are really good examples where we could do that. So let's add that to our to-do list. So I wanted to steal 5 minutes from those 20 minutes to talk about two new documents about deterministic encoding. There's a lot has been said about deterministic encoding in various venues, and it's sometimes a little bit difficult to explain things because 8949 is pretty terse, and it also tries to give applications enough rope to actually do something that specific application may need. But there is something like well-defined form of deterministic encoding that some of us have implemented. And it turns out these implementations simply interoperate without us even talking about that. So I finally sat down and wrote a backgrounder, an informational document about deterministic encoding. So you cannot make a lot of examples about deterministic encoding because it just happens. But you can explain things and also explain how the application is not out of the picture, but actually has to do its share when deterministic encoding is required. So that's one document that I would like to develop, probably on a slow burner because it's useful as an internet draft. But it would be good to hear from people who are gaining experience in the deterministic encoding space. And just to benchmark, check out this backgrounder document, I took the DCBOR specification that we have been talking about and essentially extracted everything that can be said is different from what 8949 says. And turns out that essentially the numeric type reduction is what's new, what's different about DCBOR. So I simply wrote this up. I think it's not much more than a page of actual content for this specification, and it shows that if you have a good backgrounder to work on, then it's not very hard to actually describe these things in the terms you now have available. So I would like to know whether these documents are useful. On the DCBOR document, We haven't really decided whether we need this. But for me, it was a good exercise to actually first write it up, so we know what it actually is. Because right now it's a very long. The input document was a very long specification, and it repeated a lot of things from 8949 that don't need repeating. And I even wrote a document about restatements that explains why that is a bad idea. So getting some initial reviews on this would be a nice thing. So end of advertisement block. Yeah, and finally we have the some more active work. So we will talk about DNS-CBOR in a moment. There is this draft about using CDDL for CSV. I don't think any of us can fully escape CSV in the daily lives. So I think that could be a draft that touches you. And there's another draft that tries to extract CDDL data models from RFCs to make them more useful. Because if you just take your random RFC, then you might find some errata that needs to be applied before you actually can use the specification text in there. And then there is the draft numbers process document, which I think already has turned out to be useful, but which certainly needs to be refined with experience from using it. So that's my part. If there are no more questions, we could go to the
Okay,
next.
discussion. Michael.
Thanks, Karsten. Appreciated the DCBOR draft because that was very helpful to actually have it like concise and down to kind of key adjustments, changes. The one thing that jumped out at me was the reduction of, floating point zeros and integer zeros down to 0 and negative space and things like that. Was there anything else that we should be noting aside from like -0 and 0 or now 0?
You mean noting in terms of?
Yeah, were there anything that jumped out at you that would cause an implementer like pay very careful attention to this? Like any particular segments there in your mind aside from the adjustments to handling of 0?
Yeah, the other part that is somewhat interesting is the handling of subnormal floating point numbers. So we haven't really talked about floating point very much in this working group because it started out with constrained systems, and constrained systems often don't even have floating point. But the observation is that what is a subnormal number, of course, changes between float 64, float 32, and float 16. So even thinking about special processing for them destroys this beautiful unified number space. So you cannot really do that.
Yeah, that's helpful. Thanks for calling that out because I'll pay closer attention to that section because we've been using COSE on detached signatures on some machine learning things that obviously sometimes get into large number space. So that's helpful. Thank you.
Yeah, on machine learning, I would maybe want to add that there is a document in the making that looks at the number formats, at the floating point number formats that are becoming more popular for machine learning, like FP8 and bfloat 16 and what's it called? I forget the name of the third format. So that might help with those.
Hi, Wolf McNally, Blockchain Commons. Our original spec for DCBOR, our original proposal for DCBOR, the subnormal number issue was called out as an issue for future work. It's not particularly relevant to our work at this time, although, looking at the IEEE 754 specification, it's clearly part of that specification. The numerical encodings in CBOR inherit that. And so we wanted to make sure that, it would be responsible to call that out as something that while we weren't particularly going to apply energy towards that we realize that at some point the community may need to. Similarly with big nums and things like that, which was in our first draft, but we took out of our second draft because it's not particularly relevant to our work, but we recognize that numerical reduction probably ought to apply to those too, but not something for our initial specification, which mostly dealt with integers and floating point values of machine size. And so we wanted to kind of lock those down because those are relevant to our work. I think that the spec does a pretty good job of it as we had it. The main thing that I think that I want to make sure that you're aware of, Karsten, when it comes to your drafts that you're currently writing, is that 8949, the section on deterministic encoding, states those things, for example, like sorting map keys and so on, as not necessarily required, or that decoders of deterministic CBOR that are expecting CBOR that's encoded deterministically should actually reject that as invalid. And so I think that anything going forward that basically says that, numerical reduction of 0, for instance, there's, CBOR has several encodings of 0, and minimizing that in terms of the integer space is pretty well accomplished by everybody, but minimizing that from floating point to integer is not. And we want to make sure that CBOR decoders have to reject a floating point 0 if they find one, because it's not it's not deterministic. And again, how this applies to other number types, rational numbers or whatever, and big numbers or whatever, not part of our current work, but we recognize that it's for future work. And so I would just want to make sure that what you're working on is actually strict. We're not presuming that Postal's law applies here, that we want to be strict in both what we read and write when it comes to determinism. That's my main point.
Yeah, thank you. Okay, I think I'm done.
Okay, next up is DNS CBOR. So do you want to run your slides? Okay.
I think you
need to request.
Yeah, okay.
Yep. Go ahead.
Okay. Yeah, as already was introduced, I'm talking about DNS CBOR, which is a concise binary object representation of DNS messages. And yeah, I'm Martin Lenders. Sorry. Yeah, the motivation is basically that when we look at DNS traffic nowadays by consumer IoT devices, which is this somewhat wild graphic here, we see that we easily reach fragmentation for most of the names that we see. And so we need to compress DNS messages somehow. And basically, that's the idea with application DNS CBOR, not necessarily use compression, but also make the DNS messages more compact. Yeah, and we try to be concise by first of all encoding DNS messages in CBOR, and then also omitting redundant DNS fields in the queries and responses. And we also allow for address and name compression using packed CBOR, as was hinted at by Karsten already before. Yeah, and we didn't do much since the last IETF, since we worked more on DNS over co-op, to be honest. But after IETF117, we plan to work a lot more on this draft. So we only clarified that the compression algorithm for the packed CBOR is up to the implementation and discussed the format decisions on packed CBOR. And also we did some structural cleanups and syntax bugs in the examples. So another thing to report is that I implemented a decoder and encoder in Python during the hackathon this weekend. And basically, there have already an encoder. We found a lib name thanks to Marco, and And but the decoder is almost done. The packed CBOR support there is still missing. And yeah, some lessons learned during implementing this is that some of the elision we wrote into the draft may need rethinking. For example, I ran into the case that I didn't really need the question section, but there were additional and authority sections in the message. But the draft basically says if there are these sections, then you need to have a question section. So yeah, we need to maybe rethink a little bit about that. And we also might need some dedicated specs for pseudo resource records, for example, options, because they can take up a lot of space when we just use the byte encoding for that. Okay. And for the next steps towards the version 4 is that we provide and compare examples of the compression algorithms. Then there was an DNS DEAR feedback that we need to provide, that we provide a comparison that is basically going in the same direction. And of course, we need to address the lessons we learned from the hackathon. And yeah, the next steps will be that we further work on the implementation and also do an in-depth evaluation of this. And then there is also this potential of a global compression context. And this morning on the mailing list, maybe some of you read it, Christian had a really nice idea to maybe use the packed argument for the media type somehow to say what compression context you want to use for that. So yeah, that is from my side. Are there any questions or comments?
Discussion of DNS CBOR. Tick, 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 tick.
Yeah.
We have someone going up to the microphone, and then Karsten, you're next.
François Nguyen, I can't figure out how to use the app.
Okay, that's fine. Go ahead.
So you have a...
Tell us who you are, though, please.
My name is François Nguyen.
Thank you.
It's my first IETF.
Nice.
So you have an encoder, but you don't have the decoder yet. So
we have a decoder, but it's not capable of handling packed CBOR yet. It's just something that I didn't manage to do in time during the hackathon.
So do you have a dissector for Wireshark to look at what you're doing? Or?
No, we don't have a dissector yet. I used some DUNS for testing from PCAP, but there is not a dissector yet, no.
Okay. Will you need someone to help you with this?
If you want to help with that,
okay.
I'm totally happy. But as you might have seen, there might be some changes happening to the draft for the next version. So maybe wait for the next version before you start.
Thank you.
Thank you. Carsten?
Yeah. Yeah. My main question was, when are we going to discuss numbers? How much do we save? Which of the next interims can we plan to do that?
I hope, as I told you and now also the people, is that after this IETF, I will have much more time to work on this. So then I will, probably then at the next interim, provide some numbers. But yeah, depends a little bit all on my time.
Yeah, it's always very hard to look at these proposals if you don't see what they actually do to actual DNS traffic you would get to compress or to pack. So
totally
that's why I'm asking. Yeah, great. Wonderful.
Okay. Any more questions? Then,
okay.
Thank you.
Thanks. All right, let's okay, next thing on the agenda is DCBOR. I have no slides that anyone submitted for that. So I guess it will just be discussion. Wolf, did you want to start any discussion on that? As he comes up to the microphone.
Hi, Wolf McNally, Blockchain Commons again. Yeah, our original proposal for DCBOR was motivated by the fact that we work with both blockchain and not blockchain companies that are interested in determinism, which basically means that different encoders of the same data should all converge upon the same bit sequence, essentially. And we identified CBOR as the best candidate for that, especially because it had a specification for determinism, for example, including sorted map keys and so on. But as our clients and we often mix various kinds of numeric types, including integers and floating point values, we realized that this was something that CBOR didn't really address. And so I wrote an internet draft after having written some code as well that did address it. The length of it, as Carsten has pointed out, was primarily due to the fact that I think that determinism can't be fully accomplished at the encoder level. It needs to be something that where the protocol designed on top of CBOR also needs to address that. And so our draft was intended, maybe it was too big in scope, but it was intended to address both those issues and not leave those stones unturned, because I think they're important. Carsten is obviously more interested in the protocol level, and I think that's what his drafts are about. I concur that's important to kind of get that minimally specified. Obviously the controversial thing that we talked about is what we're calling numerical reduction, which is that each numeric value should have exactly one representation if it can. For example, 0, there shouldn't be 0, 0.0. JSON has, essentially you can have an infinite number of ways to represent 0 in JSON. And that has to be canonicalized using things like the JSON canonicalization scheme and so on. Well, our protocols that we're designing on top of CBOR, we wanted to take care of as much of that at the protocol level as possible. And so we have 3 implementations of Gordian DCBOR, which is what we're calling our variant of this, which is well-formed CBOR, but you hand it off a 0 in any form, it always encodes as just byte 0. We have implementations in Swift, Rust, and TypeScript. If you're curious about that, I urge you to check that out. And a side benefit of this, aside from being more deterministic, is that in languages that have weak number typing systems like TypeScript and so on, you don't have to wrap your numbers in declaratory wrappers or use builders that specify whether it's an integer or a float, because TypeScript doesn't care. Other languages that do care, you still just present the value as it is in the language, or you tell it what kind of value to extract. And if it can extract it without losing any precision, it does. So that's a side benefit of determinism. There are, as I mentioned, some unaddressed issues that aren't particularly relevant to our work at this time, but we want to call out and make sure that the community understands them. And so, I certainly welcome any questions you have about either our motivations or our execution of this so far. When we attended IETF Dispatch earlier this year, they basically said, hey, yeah, this should be a CBOR work group item, so that's why I brought it to you. We would like to see this either become part of the CBOR specification. It's strictly opt-in. So as I've said, if you're writing or reading deterministic CBOR, you can't just read or write any CBOR. But if you write deterministic CBOR, it's perfectly fine CBOR. Anybody should be able to read it. That's but determinism basically does place some limitations on it, but those are important for the domains we're operating in. So I welcome any questions about that.
Christopher
Allen, also with Blockchain Commons. So the 3 releases now are in what we're calling community review. So we have one in Rust, which is what the cryptographic community prefers to move things to. We have one in TypeScript to demonstrate that we can handle a less strongly typed language, and we have one in Swift for mobile on iPhone. We would love to see somebody do, say, a Python version, because that's another one that's very popular in the various cryptographic communities, and a lot of things like HPKE, et cetera, are described in Python API functions. So if you are interested in porting one of these or being involved in the community review to really pin these down and make sure there isn't any security problems with these, we'd love to have your eyes on the code. Thanks.
Okay, Michael.
I guess this is probably a question for Christopher and others on the other DC board draft. Is if the working group were to adopt Karsten's draft around deterministic CBOR, which I found very readable, would that prevent you from doing what you need to move forward, or could you contribute to the draft as it moves forward as part of the working group? Because that seemed like a very good starting place for saying, hey, if you need determinism, here's a way to do it, and go with that.
Yeah, Wolf McNally again. I would say that based on hearing Karsten's concerns and reading the drafts he's read, I'm ready to edit mine way back actually and remove a lot of the things that that Karsten felt I think were out of scope for DCBOR. In terms of like we had a number of proposals for people who specify APIs, not for API specifications, people who specify APIs, what things they should consider. As far as the protocol level is concerned, that's kind of I admit that's out of scope. So whether the group as a whole chooses to go with Karsten's draft that we amend, or whether we do an 03 or a 04 and that moves closer, that's fine too. It's not a matter of ego for us. It's a matter of getting work done that we can actually build on. And so whatever the group thinks, since I'm the new person here, I'm happy to take whatever advice the group has in terms of how to proceed moving this along the track.
So I was just going to add, so one of the other questions is it worthwhile? I mean, IETF doesn't do APIs, and we basically are, very much have a particular orientation for that, which is not appropriate for the internet draft on DCBOR. And so the question is, should we separate that out as another work? There are some interesting things in regards to how you approach being very safe with your representations. So where does that work go? And what, we'd love to have your advice as to, do we need to continue to revise our draft, or, focus on, finishing up Karsten's draft or reviewing whatever. I mean, it's pretty solid to start off with. So we're really looking for guidance. Thanks.
Lawrence?
Yeah, Lawrence Lundblad here. Carson's draft seems like a good starting point to me. It seemed like it was kind of cut right down to the important stuff. I'm generally supportive of that. I'm interested in implementing it in my CBOR decoder encoder. That's the thing. My main question that's stuck in my head here is, how do you avoid subnormals? You can't control the floating point hardware, all right? It's going to put subnormals in there for you if you want it or not, if you do some calculation with them, isn't it? I mean, maybe I'm missing something, but that seems like that's a pretty sticky problem that to try and solve that one.
So I am not this is Wolf McNally again. I'm not a numerical methods expert. My understanding of IEEE 754 is that all implementations of 754 should be bit for bit deterministic on various kinds of operations. So if something yields a subnormal value, which is a value very close to 0, I believe, that it has bit encoding. And the way we handle that in our numeric reduction code is we attempt to reduce down to the next lowest level and then scale up again. And if it doesn't match bit for bit, then it's not reducible. Therefore, at every step, we're following the 754. We're not just twiddling our own bits and figuring out, oh, this is reducible. So if a subnormal value is produced, it should actually take whatever level of representation. If it's, say, a double, and it's a double go very close to subnormal, and you cannot scale that down to a 32-bit float and then float up again and have the same value, it won't be reduced. So that is my understanding of the default behavior. I'm very open to hearing from other people who have a lot more knowledge of numerical methods than me, whether that's a valid assumption or not. But it's our current assumption going forward, and you know, but obviously I think that's why we flagged it as future work, not something that's directly relevant to our work. Does that answer your question? Okay.
Lawrence said maybe. Lawrence, if you have more to say, go to the microphone, please.
Maybe I can answer part of that, because I implemented this in 2013 when we standardized CBOR, and generally what Wolf just said, scale down and then up, and if it's still the same, then you could scale down. That's of course the implementation strategy that I also used in 2013. The point really is, if you cannot rely on your floating point unit to be a full 754 unit, then you really have to do, which I believe Lawrence did, and do the deterministic encoding using shifts and masks, because the floating point unit just won't meet the specification of deterministic encoding, and therefore you are essentially forced to implement this by hand. I mean, it's not a lot of work. It's like 7 lines of code, which actually are in the standard, so you can just copy them out and translate them to your language. But I think that's really the less interesting part. I mean, it's you need to put work in, but it's not much work. So the other part is, these numbers actually come from an application that probably doesn't just copy floating point numbers in its lifetime, but actually tries to compute with them. And then, of course, you run into a problem with deterministic encoding, because another application that might want to do exactly the same calculation might have a different floating point unit and actually come out with a different answer. So if you have a reduced to zero floating point unit that doesn't deal in subnormals, but just puts all of them into zero, then your application level data at the end won't look like you were expecting them to do. So this is really a problem, and of course that's not a new problem. Floating point always has had this problem. It was actually in the language scheme, the floating point numbers are called inexact, because you cannot expect to get exact answers. So this is really, I think, the more complicated part. What I'm really interested in, what's still missing from the deterministic backgrounder document, is something that I haven't implemented, because I have only implemented this, both deterministic encoding and DCBOR, for a language that's polymorphic by nature. But if you have a strongly typed language that separates floating point and integer, then of course, when you pick a number of the wire, whether that is one type or the other type depends on its value. So good ways to actually convert back to the application types as they may be required. I would be interested to have some feedback on that, so I can put it into the backgrounder document.
Okay, yeah, I'll address both issues. I think it's true that, for example, our current implementation, our current draft probably should say that we're relying on a stable implementation of IEEE 754 for it to actually be valid, and that anybody who claims to support this draft either needs to have that in hardware or software, but they need to have it. And I think that could probably be called out very specifically. The other issue, the second issue you raised, I'm trying to remember what it was.
I think the right type when decoding things.
I'm sorry, repeat yourself, Karsten, sorry.
getting the right type. So if you have an
Yes.
application,
Okay. Yes.
in-
I have it now. Right. Sorry about that. Yeah. So I've implemented the DCBOR spec in 2 strongly numerically typed languages, Swift and Rust. Basically, the approach I take, which I think should be the regular approach, is when a numerical type is encoded, you don't necessarily know how it was encoded. You could parse the CBOR yourself. In fact, our CBOR implementations let you look at it as CBOR structured, as parse CBOR structure, and determine is it an int, is it a uint, is it an int, is it a float, is whatever. You can look at it at that level if you want, but the base API just says extract this as this type. So, for example, if I have what I think is a byte stream, of some kind, like an array of uint8, and it's encoded that way, and the protocol built on this says it's built that way, then I should be able to iterate through that array saying extract the next uint8, extract the next uint8. Now, if a float has been thrown in there, well, that will throw an exception in the API because it can't be extracted at least the precision at which it was recorded. Whereas, if, for example, if you go through the same array of integers of numeric values and say extract this as a double, extract this as a double, extract this as a double, it will obviously decode unless, for example, there's, let's say, a big number thrown in there. But we were also reserving big number for future work. So we're not specifying how big numbers are to be handled. So the idea is that anybody who implements a DCBOR codec can decide, what's the maximum numerical precision they're going to support and support that. So if you're not using floating points, you don't need to support floating points. If you do support floating points, you need to support at least binary 16, and up to binary 64, which is the IEEE 754. Does that answer your concerns?
Yeah, I think the pointer to pull APIs that carry an expectation of what the application type should be, that's really answering my question.
So in your experience, has the floating point implementations been deterministic and do what you expected?
Yeah, our use cases for floating point are mostly dates currently, actually, and because they're not near 0 at all, they never get encoded as subnormals, and because they tend to be scaled up to like nanosecond values and so on, delivered by the operating system, they tend not to have any of the strange edge cases that we've been discussing. So, but other than that, I wouldn't anticipate any problems. Obviously, we're not doing advanced mathematics on that at this time, and that's why my qualifications as not a numerical methods person, I think, are satisfactory for now. But again, future work.
Then one more thing that I don't know if we've discussed it, and that's the NANs and NAN payloads. I don't know if there's anything to deal with on that. And there's quiet NAN and all that.
So I researched the NAN issue before speccing it the way I did. And what I realized is that there is no, that quiet NANs versus signaling NANs is a processor level artifact that basically, certain kinds of libraries in certain conditions sometimes output signaling NANs, meaning there should be a trap in the code, as opposed to quiet NANs, which are supposed to be just passed on in the algorithm. And that whether something is a quiet or signaling NAND generally has nothing to do with how it's encoded. Now, encoding NANs is important, but also 754 has NANs which are supposedly a singular kind of value, has a number of undefined they call payload bits that have no semantic mapping to anything I was able to determine. And so since we're trying to create a subset of CBOR that encodes that has unambiguous encoding, if I want to pass on a NAN, it shouldn't matter how it was generated, shouldn't matter whether it was signaling or not signaling, because it's not going to make a difference on the delivery side. And if somebody wants to show me a use case where it would make a difference, I'm happy to do that. I've already changed my stance about one thing on DCBOR, which had to do with null map values. I thought that it would be unnecessary, and I was convinced otherwise. So so I'm happy to look at use cases, but as far as I can tell, a NAN is a NAN, and that it has a 2-byte unambiguous encoding, which is the minimal form in CBOR, and that's how DCBOR should always perceive it. And any other encoding, whether it's payload bit on, should be rejected because it's not deterministic. It's still a NAN.
Yeah, I think NANs are interesting because you will find NAN payloads in the internal implementations of languages like Lisp, Lisp-related languages, Ruby, and so on. But you will never actually see them leak to the programming model of that language, because it's all happening within the interpreter, within the JIT mechanism. So I think we are pretty safe with reducing nans to the single nan value. But if we don't, then we still have typed arrays to actually do something weird.
Yeah, if I could actually address one other thing that I'm not sure we reached consensus on yet is I made a choice as well to, in my current draft to, it's in the editor's draft, it's not in the last release draft, to restrict negative 65-bit integers, which CBOR can represent, which are well-formed CBOR, but are out of machine size for most processors, and I think properly should be represented as big nums. And so to ease implementation, especially in constrained environments, when decoding DCBOR, I basically made those invalid bit patterns, declared them as invalid. So if you need negative 65-bit integers, you're out of luck in my current spec. Now, if there's an argument to be made for otherwise, and basically that comes as almost no cost. It's one compare. So, you know, that's a decision I made, which, you know, is that fair? I think it's fair given the other concerns, and it definitely falls in the realm of determinism.
Yeah, you need them if you actually do big nums. Yeah, but I leave the floor to Christian.
Yeah, obviously they're representable by big nums or other forms, and I think that properly, you know, I feel like because they take you out of 64-bit scope, which is the common top for processors right now, and because we want DCBOR to be easily implementable in a variety of constrained environments, we'd rather invalidate those bit patterns at this point, unless there's a really good argument to keep them.
Well, there are good arguments, and if the backgrounder document is not describing them, then please send me a note and I will expand that.
Okay, I will look at that more carefully.
Thank you.
Christian Amses, Chair Head of. There is one note that I'd like to add on the topic of how do you deal with floating point units that produce calculations that are inconsistent. My understanding is that at least for the DCBOR use case, Wolf, that you have described, the idea is that implementations don't arrive through through computation, but they might be storing the floating point numbers in some process and then reconstruct the CBOR. They won't be doing different calculations. They just store them and re-encode them, and they'll try not to store the encoded CBOR, but just the parsed value. But as long as they don't calculate with them, I think they should be safe. And a note that it is like it is because of that might help understand the document better.
Yeah, I'd say if you're creating a protocol where several actors need to perform floating point computation separately, it's out of scope for DCBOR itself to specify how they arrive at that. But and this is why, again, I say you can't solve all these problems at the codec level, but you should solve as many as possible at the codec level to remove cognitive burden from engineers worrying about how things should be or will be encoded when it's unambiguous, when you're not going to lose any precision and you can guarantee you're not going to lose any precision. But how you arrive at those, how separate actors arrive at floating point values and then that they arrive at the same value, that's totally out of scope. That's something that should be called out as important if you're going after determinism.
Okay, we're just about at the bottom of the hour, so we're just about done here. Just one more thing is on the agenda to go over the dates for the interim calls. The dates that are up on the screen on the agenda are in the same cycle that we've coordinated with the core working group, alternating weeks. So it's again Wednesdays still at the same time, 1400 UTC. On the dates on the screen, August 23rd, September 6th, September 20th, October 4th, and October 18th. Does anybody have any reason we should not use those dates? Okay, I will post those to the mailing list just to make sure everyone knows about them, and then we will request them from the Secretariat. And I think that finishes us up. I just want to thank Marco Tiloca for, again, taking notes. He's always willing, and we're always happy that he is. So thank you so much. We are adjourned. Enjoy the rest of IETF week.
Thanks, everyone.
Thank you all.